Hello, this YouTube video is a follow-up to one I published on YouTube before called the Double-slit experiment, demystified. So what I didn't mention in that previous video is something called complementarity, which I'm going to explain now. So this represents a double-slit experiment. This over here is a gun that fires electrons or atoms. This in the middle is a barrier with two slits in it, which is why it's called a double-slit experiment. And this over here, this is a target screen upon which a pattern of dots might appear. What complementarity means is that you see a wave pattern on the target screen only if you do not know which slit was used by a particle. If you do know which slit, then the wave pattern goes away. And a lot of experts have had total nonsense, a mountain of nonsense to say about that. I'm going to explain it in terms of the elementary waves I've been speaking about. Now, in order to explain this, I have to use a little bit of mathematical language, which is a problem because 95% of the people viewing this video can't stand mathematics. So here's the deal. I'm not going to use any equations, but I am going to use a little bit of language about linear partial differential equations, PDEs. So there are three rules governing complementarity in this double-slit experiment. Rule number one is that in general, elementary waves which go this way, the opposite direction as the particles, elementary waves adjoining each other usually cannot interfere or interact with each other at all. They ignore each other. Rule number two is that if elementary waves come from the same single point on the target screen, then they interact. Then there is a linear PDE, which means that you can add or subtract elementary waves together and you get wave interference, which is why any one point over here on the target screen, you'll get wave interference over here in proximity to the particle gun. There's no wave interference in proximity to the target screen. Rule number three is that if you put a small lamp in, then the energy of that lamp, which is infinitely more than the energy of the elementary waves going in this direction, inactivates rule number two. So let's consider rule two first. Any one point on the target screen puts out elementary waves which go through the two slits A and B in this direction. And because there is a linear PDE, they are both solutions to that linear PDE, and therefore they can interact, and that's why there is wave interference in this area. However, if we look at all the different points on the target screen, adjoining points put out waves with different PDEs, so you cannot add those waves together. So therefore, these waves coming from the target screen, adjoining points don't form a wave in the form of a plane moving across like this. That's not in the nature of elementary waves to behave that way. Now, as you know, we're going to put a small lamp of infinitesimal energy in this area here, but the energy of that lamp is infinitely more than the zero energy of the elementary waves going in this direction. And that is rule three, which inactivates rule two. So therefore, the elementary wave coming through slit A no longer interacts with, is no longer governed by the same PDE as the wave coming through slit B. Slit A has its own PDE, slit B has its own PDE. The waves don't add together. There's no wave interference over here. And believe it or not, that explains all of the data, as I will show in a moment. Now I will say the same thing without any reference to mathematics. In order to know which slit is used, we must introduce a tiny lamp and detector inside the equipment. Now let's say that it's a lamp that emits an infinitesimal amount of energy. The infinitesimal energy from the lamp poisons the elementary waves, which carry zero energy, poisons those waves as they pass backwards through the two slits, so they no longer cause wave interference. By this we mean that the waves forget that they were born at point Z. The wave coming backwards through slit A thinks it was born at slit A. The one through slit B thinks it was born at slit B. Therefore, there is no wave interference. Now, the wave pattern on a target screen, what does it mean? That wave pattern is a picture of the wave interference of elementary waves impinging on the particle gun. But we just said that if the lamp is on, there is no wave interference, and therefore the final pattern on the target screen will show no wave interference. It is what you see on the right side of this picture. As we turn the little lamp off and on, and off and on, notice what happens to the wave interference impinging on the particle gun, and what happens to the pattern on the target screen. So that explains complementarity. Now, stepping back from complementarity, let's talk about the big picture. In the big picture, what do you find? You find that quantum mathematics is dead accurate, but the quantum picture of the world is for crap. It doesn't make any sense. So what does that suggest? What it suggests is that there is symmetry in nature, like a mirror, and quantum mechanics is on the wrong side of the mirror. Quantum mechanics would have you believe that that is the real me. Whereas both sides of the symmetry have the same mathematics, quantum mechanics is looking at a mirror image of reality. How could that be? Well, consider the double-slit experiment. Quantum mechanics says that wave particles go in this direction, whereas in nature what actually happens is the waves, elementary waves, go in this direction and the particles follow them backwards. So quantum mechanics is calculating the amplitudes, or if you're Feynman, you're calculating the propagator, whereas in nature it's the negative amplitude or the negative propagator. How could they both end up with the same answer? So to get the probabilities, you have to square the amplitude or the propagator, and you get the same answer. So that explains why waves can be going in this direction and give you the same mathematics as if you mistakenly thought there were wave particles going in this direction. The purpose of TEW, the theory of elementary waves, is to restore your brain to a state of wholeness. We'll show you now our method for undoing some of the damage done to your brain by quantum mechanics. This is your brain, and this is quantum mechanics. Thank you very much for your time and attention. If you like what you've seen, please subscribe and hit the like button below.